All right, so for this question, I wanted to have a little discussion about this histogram. So give you a little context for the problem. All right, this is about the length of a hospital stay for female patients that were admitted to hospitals in New York, all right, for 1 year, and their primary diagnosis was acute myocardial infarction, which is known as a heart attack. Okay? So just look at the histogram. All right, yesterday I taught you guys that the first thing you should do when you look at a histogram is think about the shape. So how would you describe the shape of this histogram? A hump and skewness. Very good. So let's get a little bit more specific. All right. I know that this is a pretty large bin, but I think the main hump is here. So it's going to be unimodal. And which way is the tail going? To the right. So the right. So in part B, we're going to start in part B. You're going to write this distribution is unimodal and skewed right. So let me just give you some more context of what that means about skewed to the right. It means the majority of our female patients for this year, these hospital stays, were probably less than 10 days, right? Here's 10 days. So the majority of our hospital stays are less than 10 days. But as you move to the right, you're getting very few women that are spending a long time in the hospital, right? 20 to 25, 30 days. You're talking about into a month they're in the hospital. All right? So because you have very few women that are spending a long time in the hospital, it's causing that skewness to the right. Okay? Now, after shape was center. Right? We just did shape. Now it's center. Measures of center are median and mean. Okay? Now, do I know the data values in this problem? No, I don't know the exact data values for all of these women and their length of hospital stays. So I just have to eyeball the median. What do you think is the middle of this histogram? 20 is here. I don't think that's the middle. I think that's the middle. Hold on, this is a good question, or a good statement. I think that's the middle of the axis, but I don't think that's where the median or the middle number would lie. I think it's probably somewhere in here, right around the big humps here. So I think it would be something around 7. Basically a week in the hospital. So I'm going to write the median is about 7 days. All right, and if you put 6 days or 8 days, something around 7, right? Again, I don't know what it is, so I would accept numbers around 7. Now, if you put 20, right? If you put 20 days, I would not accept that. That definitely would be wrong. Okay?
Wait, why?
The median is like, you're trying to think, what would be the middle number, right? If you list it out, right? See all this bar here? That's 1. So this is over about, let's say, 500 women spent 1 day in the hospital. So that means if you thought about it, we're not going to do this, but you'd have 500 ones written out. Then you'd have 275 twos, right? And so you're trying to find what's the middle number. So I think it's about 7. Okay, a week in the hospital. Okay, now the spread. Because we don't have the actual data values, you're going to eyeball the range. What do you need to calculate the range? The biggest and the smallest, right? So let's look. The biggest looks just past 35, so like 36, 37 days in the hospital. And the smallest, as we said, was 1 day. So if you subtract 36, 37 minus 1, you get the range is about 36 days. All right, so just over a month. That's the spread. That's us describing the spread. Very good, Kylie. That's us describing the spread. So shape, we said it was unimodal, skewed right. Center, we said the median is about 7 days. And spread, the range is about 36 days. Those 3 things you have to describe every time. Yes, Camilla. So I think there is like this little hump here. I guess it's a big hump here. Can kind of throw you off. But I really do think there's kind of one main hump around 7. The reason I don't put bimodal, if you look back at your notes from yesterday, let's see if I have them here. Yep. So when we were talking about this yesterday, Camilla, I think this one here in purple is bimodal because you can clearly see like two separate histograms, right? It's kind of like split almost like that. All right, if I don't see two separate groups like that, I don't really do bimodal. So that's why I still think this is unimodal. All right, but you could mention, it's not a bad thing to mention, Camilla, you could say, I think it's unimodal, but I would see that a good portion of the women are only spending a day or less than a day in the hospital. It's not a bad thing to mention. No, so unimodal is like if there's one hump, you got to do something about that, and then the skewness is the tail. Those together describe the shape. Okay, let's go back to A. Okay, now this is going to be, what we just did really is not on the SAT. What we're about to do here is on the SAT. Okay, remember, you told me this was skewed to the right. Okay, now the reason this is important is because that skewness, okay, that skewness is going to mess with some of our statistics. All right, more specifically, it's going to cause the mean to move towards the skewness. And what I mean by that is that number is going to be pulled to the right. Okay? So what did we say our median was? About 7 days, right? So because of that skewness to the right, the mean is going to be something above 7. So in question A, it says, would you expect the mean or the median to be larger? And you would say the mean, because the skewness to the right will pull it above the median. All right, and that's a concept you're going to need for the SAT. Kylie. So do you see how we kind of have one main hump, but it kind of trails off to the right? That's what I mean by skewness. Okay? And you can also have skewed to the left as well. So either direction. So like this one right here, I'll just show you. So like this would be like unimodal and roughly symmetric, where it's kind of like one hump. There's no like tail in either direction. All right? And this one would be like skewed left.
So skewed left, you would say the median, because
the median would be smaller. Oh, I'm sorry, you're saying median is higher? What are you saying? You say it again. You go.
So if the skew was towards the left.
Yeah. What's being pulled towards it? The mean is being pulled. So the median would be higher. That's what you're saying. You're right. Your brain's got it. Okay? The mean always gets pulled towards the skewness. All right? So if it was skewed, like this one here, like skewed left, the mean would be pulled to the left. So the mean would be lower than the median. You got it. Yes. No, not negative. No. We're not, remember, this is real values, right? No negative numbers. No. I'm just saying, like, if we're not at the end yet. So let's imagine, have your brain do this, right? Have your brain put all of the main, like, big bars over here and the little bars here. So it'd be skewed this way. So it means the mean would be pulled down. So the mean would be lower than the median. Okay? That's all it's saying. All right, but no negatives. Okay. Yes. Oh, what are you saying? What is always the case? That the mean is pulled towards the skewness? Yes. No. Okay, yeah, that's true. If the mean, so what I would say, Viana, the first thing your brain needs to know is the mean is pulled towards the skewness. And then from there, you should be able to figure out which one is bigger or smaller. Okay? Because they might not phrase it like this. They might say, is the mean smaller than the median? Right? They're going to mess you up with like the different names. Yeah.
So you know how you said that the unimodal was roughly symmetric? Is that the only?
If this had been like this would be unimodal and roughly symmetric.
Yeah, but.
So that would be where the mean and the median are about the same, because it's not being, the mean's not being pulled in either direction.
But could another one be Like the bimodal?
Yeah, you can have bimodal that's roughly symmetric, but if you're, like I said yesterday, if you see something as bimodal and roughly symmetric, really, if you had all the data, you would just split it into two groups and look at two unimodal and roughly symmetric, because clearly you've got something going on. You should just separate them.
Is that likely or?
Yeah, I mean, that happens all the time. The one I was doing last year with my stats kids was the average weight of offensive lines and then like position players in football. So the offensive line was much heavier than the position players. So you just separate them. Only look at them as separate things. Okay, now part C. This, I'm going to tell you in part C, but this is not on the SAT, but I want to just say it for you. Okay, it says, what would you choose to summarize the center and the spread for this distribution? Okay, now look at the shape. What did we say the shape is? Unimodal and skewed right. So the question that my seniors have to ask themselves is this unimodal and roughly symmetric? It's not. So if it's not unimodal and roughly symmetric, you write median and IQR. And the IQR is the interquartile range. Right, this is Q3 minus Q1. Okay, basically why we do that, if you want to know why, we do that because the skewness is messing with the mean. And when you mess with the mean, you mess with the standard deviation because you calculate the standard deviation based on the mean. All right, so the skewness messes those up. All right, and we don't want to deal with statistics that are messed up, so we deal with median and IQR because the skewness affects the median and IQR less because median and IQR is not about distance. It's only about location, right? Where it is in the list, right? Mean and standard deviation is about distance, how far away things are, okay? So if it's not unimodal and roughly symmetric, you're doing median and IQR. Now, what if the shape had been unimodal and roughly symmetric? What if the shape had been unimodal and roughly symmetric, like this one? No, you know what we're going to have? That would be bimodal. If it's unimodal and roughly symmetric, then you would be choosing mean and standard deviation, all right? Because those statistics would be fine to use. All right, so that's what my students, my seniors, have to know for their test, okay? If it's unimodal and roughly symmetric, they can use mean and standard deviation. All right? Okay, let's hit it.